streaming and start recording. And if Peter, you could quickly check if the live stream is playing, or someone else could quickly check that it actually is running. I'm going to start a recording too. Great. Okay, so let me just open up our slides. So we're destroyed. We've officially changed our name. So we're officially now going to be starting break feeds. We no longer follow abide to our old create logo. So please refer to us as destroy from this point onwards. Having said that and putting that out of the way, so again, we're going to be learning a few new tricks today. So besides the talk at the back, is there anyone else that needed to get the bootstrap induction from last week? You as well? Alright, so what I'll do is I'll send 3 of you. I've already told Michael who will be helping you do the bootstrap until we fulfill all 3 of you doing 3D printing, right? So that should be fine. You just keep 3D printing and then I'll get your ZIDs separately and then you can just jump back on and join us. Okay? Michael, 3 people here, they're going to do 3D printing. Just 3D printing. Just 3D printing for these 3 heaps. Okay? Has everyone signed this form, by the way? Has anyone not filled it in? Please, like, pizzas. Please fill it in. Great. So, having said that, thank you very much, everyone, for coming. I know it's sort of like midterms and all that chaos. I think the reason why a lot of people aren't here is because there's a LEC one going on. I think. From memory, is it? Isn't it? What about Dylan? Oh, never mind. I don't know. Anyway, so the aim of today's workshop is to design a table. And it's like, oh, what kind of table? All we're doing is a table, very simple, okay? But this is no ordinary table. This is a margin table. Because, you know, I'm Chinese. And we got to do a margin table because I couldn't come up with any better ideas. And so the reason why I've chosen a table is because a table is reasonably easy to design. Okay? Because realize that we're in a workshop environment and I'm pretty much going to be trying to mentor everyone here. So it's going to be difficult for me to sort of run for everyone and try and CAD something a bit more complicated. So we're going to stick with something simple like a table. But I assure you, you'll still get a decent challenge out of it. We're going to be doing a bit of 2D, a bit of 3D. And the aim of this table is that not only will we be CADing that, but we'll also be doing a bit of assembly. Okay? And I'll get into that. But pretty much it's going to be multiple components joined together. Then once we do a bit of assembly, I'll show how to do a quick render, like you can see in the image there. I know it's a bit grainy, but that's because this render is very quick. This is like 3 seconds of rendering, whereas you can bump it up obviously as required. So that's what I'm going to be learning today. And I'll obviously attach the slides, and I'm currently recording it, so if the recording does fail, which it shouldn't, we should be good in terms of workshop, so you can always refer to that at any point. Having said that, is everyone ready with Fusion? Yeah? Awesome. So, we're going to start with 2D. I quickly drew this up very roughly. Now, obviously, this design is very primitive. I just made this on the spot because it's reasonably okay based on what you've learned from 2D. So, you know how to do the 2D workshop from when I taught it last week. This should be very quick revision. It will take enough time for you to actually try it, but not too long that it's going to be a worry. So if you want to take photos of that, you can. Otherwise, I'm going to get you guys to do it. This is not going to be me. You're going to get about, so this is going to be your segment where you're going to go practice, and when we do the 3D section, I will run that through with you. So I'm not going to CAD it just yet. I'll maybe start in about 10 minutes myself, and quickly CAD that in about 10 minutes, but I want you guys to be trying to CAD that, okay? This is your exercise, not mine, and I want you to try and make sure it's fully defined and fully constrained, okay? Cool? Sorry, what was that? In millimeters. We always want millimeters. Inches. Never use centimeters. Yeah, it is tiny. It is tiny, but that's because I didn't want to work with big numbers. Yeah, I just kept it to millimeters. I'm designing really small, but you can always scale the model now, so don't worry too much. But yeah, all of you get started making a simple sketch. and follow that drawing, there should be enough information there to actually CAD. There should be enough information, but it's more difficult than you think. And let me know if you need any help. I'll be around. Okay? There you go. Oh my God! Yes. Sorry, I can't mind. That's okay. I already gave out first anyway. Oh, okay. What was that? I gave out yeah, this one. That's misleading. Can I like sketch on top of this? That's meant to be free. This one's meant to be free. My bad. Sorry. Hi. This thing here, it's not meant to be 5. Oh. No. This thing is meant to be free. Sorry, I made a mistake there. That's meant to be a free there. Please make that change. Otherwise, it's physically impossible. That one there is a... Change both of these to free, please. That makes it so much easier. I don't know why. I did this way at night. Radius of free. Yes, radius of all. But the position is not like. Wait. And remember, you don't have to get it exact. You just have to get a rough goal. What's up? What just happened? Huh? What does you draw on CAD? Instead of showing the hand-drawn version? No, because like I would show the dimension and then it's spoiled. I want you to read it because otherwise you would see everything. And then it's like, what's the point? You hide all the dimensions. You hide all the dimensions and you can't see the dimensions. I'll just do it live. Hang on, let me get a clamp. Let me get a clamp. And I'll show you. Alright. How's everyone going? Does everyone have something rough? Getting close? Alright, I'm about to show you. At least what I think is reasonable. You don't have to get exact, obviously. It's just rough. As long as the... Sorry, this is not on yet. As long as the top, left, and bottom surfaces are good, you're generally okay. But I'll show you anyway. Great. So, I'm going to switch to Fusion here. Rightio. So that's transition. There we go. Alright, so now we're in Fusion. I'm going to hopefully have a good mental image of that CAD. Okay. What I'm going to do is inside my workspace here, I'm going to go and create a sketch. Okay, because obviously we're going to do a 2D drawing. So I'm going to create it on the front face. And what we're going to do is we're going to draw that initial rectangle. Or the initial first few straight lines on the border, on the perimeter. So it looks something like this, which you can draw out like so. Okay, and we have dimensions for those particular parameters there. So 2.5 on the base, and we had a height of 50, a width of 10. Oh, sorry, that was 5, and this was 10. Okay, something like this. Does everyone see that? I shouldn't need to explain how you make this fit, yeah? I shouldn't need to, but I've just done that. Okay, make sure you start at the origin as well. Okay, so you have some sort of reference point. Generally a good idea. Rightio. So the trick to this one is that you have a line that has to extend out from this space corner. Hang on. Why is that extra line there? You have to start with an angled baseline out the bottom. That looks something like this. Then you have to have two circles of radius 3. Like so. So you'll set that to 3 diameter and that to 3 diameter. Yeah? So I haven't done anything that you guys don't understand. Yeah? I'm going really quick, but I hope you guys can get it. Right? 3 diameter. Thank you, Farhan. Otherwise that looks really tiny. And so, obviously the biggest question is the placement of this circle. Okay? So, if you're ever worried about the placement of this circle, right, let's take a look at the diagram real quick. You guys can see this, the live stream card, because they should have screenshots of this. You can position, the whole point of this is that you can position that circle wherever you want. It doesn't actually matter. As long as the perimeter is touching that tip there, you're free to do whatever you want. So, you make those two coincident, or you draw those up, line it up. And what I might do in this case is I might create a line, make this line here 3 millimeters, and then make this line construction, and then hook my circle onto that. Does everyone see that? So what I've done is I've drawn a construction line to vertically align my circle, right? And I've done that arbitrarily so that I can trim the rest of this bit off, right? Then what I need to do is I need to make this circle tangent to that circle. And I need to make this line tangent to that circle. And you'll notice that even after all that, there is still blue, right? Because if you click and drag this, oh, wrong button. If you click and drag this, you can still get some sort of motion going on, sort of. There's actually multiple configurations for this. So when you reach this point, you can either just leave it, or we can try and design it in a way that might work. But you can click and drag it anywhere, really, and leave that undefined. Okay, so you remember how I keep telling you leave it defined, leave it always define it? You can always leave it undefined if you're not going to change it, right? If you are going to change it, then everything must be defined. So if you really wanted to leave this defined, for example, then what we might do, right, is fix the center of the circle somewhere, right? So maybe, for example, these two might be tangent, right? And then I'll trim the rest of the lines off such that this line here is contacting this circle, coincident. And then I can perform a trim on all the other lines, like so. And, oops, wrong one there. Oop, not obsidian, not after Minecraft obsidian. Is we're going to trim this line off here. Okay, there's our final area. Was everyone watching what I was doing? I might have went really quickly. Okay, hang on. Let me undo this first. So coincident constraint is touching. So anytime I apply coincident constraint, it means touching. Does that make sense? Tangent means that the orientation is the same. So here's a scenario where totally reasonable in the sense of, whoops, circle line. Okay, totally reasonable scenario to have. Okay, totally reasonable scenario for those to be tangent, yeah? That's still tangent, right? But they're not touching, right? But the direction of this line must always be tangential no matter what, right? That's the tangent constraint. It means it's its direction and its relative placement must always be tangential, but then, you know, it's like whether it's actually touching it is a different case. Whereas the coincident constraint, if I make that point there to connect to that circle there, sorry, there you go, it means that they must touch no matter what, right? Yep, that's the difference, okay? So I'll just go over it one last time. So, all right, let me just delete all this. We'll delete that. We'll just undo everything. Rightio. Okay, so does everyone understand? Can everyone see this right here? We're at a very primitive stage, okay? I'm going to draw a line that angles out, right? Because we're going to need a tangent to some sort of line, right? Yes? We're going to tangent to some line, but I don't know the position of that line. Also need two circles that come out. I need two circles that come out with a diameter of 6 or radius of 3. Okay. Yeah? Everyone catching on with that? No one's lost yet, yeah? I'm going to try and align this point to this line. There are two ways I can do that. One is to draw a construction line that's 3 millimeters down, and then align the center of the circle to that endpoint. Or, I think this is possible. I can make the points collinear. Never mind, don't worry about that. That doesn't work. I can make that a construction line there and make it 3 millimeters in length. And then what I can do is I can apply the coincident constraint, or I can just click and drag the circle and put it in line with that endpoint of the construction line. Yeah? Then what I can do is I can apply the tangent constraint between these two circles here, right? Because I want that smooth edge, right, around the curve. And I want these two lines here, the line and the circle, to also be tangent. So I can apply the tangent constraint to that. And lastly, I need to fix the point onto the circle itself. So I'll apply the coincident constraint there, and suddenly we have a closed shape. Does everyone get that? Does everyone understand what I did? Does anyone have any issues with that? The last step was coincident. So it was pretty much making the endpoint of this line always touch the circle. Yeah? And then making sure that they're tangent as well. Yeah? Any other questions? What we're going to do now is obviously make this tangent to that line there, and then we can trim our shape and clean it all up. Does everyone get that? Have I gone too fast still? No? It's a bit funky. Alright, let's trim. So I'll open up my trim tool here, and I'll select the lines that I don't want. And so these are the lines that I want to keep, by the way. That's the kind of shape that we're after, okay? That's going to form one of the feet of our table. Yeah? Anyone have any questions about that? Does anyone not have this at this point? Some sort of leg? Okay? I'm assuming at this point everyone has the leg, yeah? Cool. Once you're done, what we're going to actually do is we're going to work in three-dimensional space now. Okay? For this leg, it's actually quite easy. All we're going to do in this one is I'm going to go create, revolve. I'm going to select the profile here, and I'm going to revolve it around this central axis here, and there's a really chunky leg. Okay? Very fat leg. Yes. It's okay. Socially acceptable to have that kind of leg. So what we're going to do is we're going to create a new body, and we're going to revolve that around using the create revolve tool. Does everyone follow along with that? Does everyone follow along with that? Can I get like some sort of like confirmation? So I'm not like, yes, thank you. Great. So, does anyone not have this up to the stage? Awesome. Cool. We're going to move on to the next step. Okay. So what we've done is we've created a leg. What I've done is we've created a nice lovely leg. Let's swap back and transition. Okay, so what we've done is we've created that leg there. Excellent. Now we're going to model the table. Okay, this table shouldn't be mechanically difficult, but there is one particular step that I do want to stress that will be reasonably difficult, and I'll get into that. Okay. So is everyone ready? Is everyone ready to CAD a table? Now this one I'm not going to supply drawings because it's way too difficult to try and produce a technical drawing and try and get you guys to mimic that. So instead I'm just going to CAD it on the spot. Yeah? Yeah? Excellent. Someone's sending me a message. Cool. So is everyone ready to go? Let's get started. Rightio. First off I've got to transition back into the right screen. Which screen is playing, by the way? I don't even know. That's the screen that everyone's seeing. Awesome. Great. So, this is our first leg. Okay? And now what I'm going to do is I'm actually going to hide this leg here. So inside the bodies menu, we're going to hide the body. Not hide the dead body. We're going to hide this object. Okay? So I'm just going to press the light bulb on it, and you'll notice it'll vanish. Okay? Dead body's gone. Okay? Now we can work on making the tabletop. Okay? And we'll get back to that later. Okay? Great. So, what we're going to do here is I'm going to create a tabletop that's going to be like a rectangular prism. Right? So you can imagine if we're making a rectangular prism, the very first step we're going to do is, well, we've got to make a rectangular prism out of a sketch. Right? So let's do that. I'm going to sketch on the top face this time, rather than the front face. And this ensures alignment, but doesn't actually matter. Excellent. So, to make a rectangular prism, it's quite easy, hopefully, for you guys. All we need to do is draw a rectangle of size, whatever, and I'm going to make mine, let's make mine 100 by 100, just to keep very nice, clean numbers. Yeah? Everyone got that? I shouldn't need to explain this process. Hopefully, with practice, this should become very seamless for everybody here. Okay, if you have any issues, please let me know so I don't go too fast, okay? Great, so we got a rectangular, sort of a square, and then now I'm going to, bless you, I'm going to now extrude the shape 5 millimeters, okay? Like so. I think it's 5 millimeters according to my measurements. Yeah, it is 5 millimeters. Excellent. Great. So, now that we have this rectangular prism, we're going to do some basic things. The first thing I'm going to do is, because when you're playing some serious mahjong, you're going to be resting your wrists on the edge of the table, which means we're going to need some fillets to make that nice smooth rest for them. So the first thing I'm going to do is I'm going to go modify, and I'm going to fillet the edges. Okay, so I'm going to go to modify fillet, and we're going to fillet the top edges of this face here, so I can go and left click each independent face, like so. Okay, I'm going to set a 2mm radius on these ones. Okay, a 2mm radius, and that's pretty much it. So once you select the 4 edges there, you can just type 2mm there and press OK. You have to extrude the face in order to create a 3D shape. You're extruding it by 5mm. Then you're filleting the edges to be like that. Yeah. Anyone else having issues? Awesome. 2mm radius. Yeah. Great. Yeah. 100 by 100, 5mm high, and then 2mm radius. Fillet. Again, if I'm going too fast, please just point it out. I'll repeat the dimensions. Yeah. Okay. Great. So now what we're going to do is we're going to put a 3mm chamfer on the base edges of this. So what might interest you, by the way, is to remove the layout grid in the viewports menu here, because we don't really need that layout grid anymore. We're kind of working already here, and when you open a sketch, it automatically previews a layout grid, so you don't need to worry about that. What we're going to do is we're going to chamfer the base edges here. 1, 2, 3, and 4. And these ones are going to do a 3mm chamfer. Okay. Why is the layout grid still there? We don't want the layout grid. There we go. Okay. So what you'll notice is now we have a 2mm fillet on the top edge and a 3mm chamfer on the bottom. Does everyone have that? Somewhat? Great. Okay. Chamfer is in the modify tools, just here, right next to fillet. Easy? Cool. So we now have a sort of angled surface on the bottom, so it makes it look a bit more edgy, and we have a fillet on the top as a solid hand rest. Okay. So we have those two checked out of the box, and we're making a solid margin table. Right. So now we need to build a recess for all the sandstone tiles. Okay. Because we obviously need those. It's not sandstone. It's like limestone, I think it is. We're going to need a spot for the tiles, right? Because obviously they're going to fall off the table if they just put on this table right here. We're going to need some sort of recess. Okay. And so what I'm going to do is I'm going to make a recess that is 77.5mm from each edge here. Okay, and the way we're going to do that is I'm going to create a sketch on the top surface, and the top, by the way, is the top with the fillet, in case you're wondering. So we'll draw a sketch on the top surface here with the fillet, of course, and you'll notice that when you draw a sketch, it automatically creates a sort of boundary, right, on any surface that contacts that sketch plane. So you'll notice that here we had a rectangle, the square, and because I drew it on the square, it automatically gives me the square as a sketch geometry. You guys can see that, right? And it automatically converts it for you. Okay, quite nice. So the next thing to do now is obviously I want to create a rectangle bound inside here that represents that offset that we're going to make, that little recess. So what we can do, I'm not sure whether we can, let's experiment, is we can offset the existing geometry here. Okay, we can offset that existing geometry because we want to keep it square, but I want to make the recess, right? So what I'm going to do here is I'm going to use offset tool. So I'll repeat that just for everyone that didn't see. In sketch, offset, denoted by the letter O. And I'll select the boundary surface here, and I'll drag it in, and we're going to subtract 7.5mm. Okay, that's the spec that I have it at least here. Okay, so our rail is going to be quite thick there, right? Past 7.5mm, we're going to recess that. So if you press OK, give us a moment. There we go. We got a rectangle there. Okay, you'll notice that it's blue But the way this has been defined has sort of been like defined with respect to outside boundary. So you don't need to worry too much. Okay. Now it shouldn't need you to put any other dimensions in there. Shouldn't need you to put any other dimensions because that's already technically defined on that offset there. So you don't need to worry too much about it if it's blue. It's mainly the first sketch of any new geometry that needs to be the case, but when we're offsetting it doesn't. Anyways, we're going to stop the sketch there. And what we're going to do is we're going to do an extruded cut because obviously we want that recess. So I'm going to do an extrude on this smaller square. And I'm going to extrude it to a distance of -2 because we're going to cut into the material. -2 there. And make sure that you've selected cut and not something like intersect, which results in this. Okay, we definitely want to not join it, right? We already have that there. We want to be cutting that material out, and you'll notice the red boundary there. Yeah? Everyone following along with that? Excellent. There we go. So now we have a little bit of recess. Anyone have any questions so far? Cool. Now we're going to do something a little bit more interesting. So we're obviously going to be mounting stuff underneath this as well. We won't get into that just yet. But what we do need, and one of the last steps in this sort of 3D segment, before we start to look at a bit more designy stuff with assembly, is I want to create a little recess inside this rail here. So you can imagine that your hand's going to rest on it, right? And I want you to imagine that there's going to be a circular recess inside this rail here. Yeah? Okay? And you can imagine that because the recess is happening over a path, we're going to use the sweep function, right? So you can imagine that if I can build a cutting profile along this rail, I can make it sweep across the rail and sort of cut this dynamic shape along the entire rail, which is going to be pretty cool, right? So in order to do that, we actually need two things, and it's two sketches. The first one is the cross-section, and I hope everyone knows what that means, a cross-section of our cut, right? So in my case, I'm just going to do a very simple arc, like a circle segment as my cuts, and I can cut that along what we need as the second item we need, which is going to be a path that we actually need to draw it around. In our case, it's just going to be a line that follows the boundary along a middle path along this shape here. So, is everyone ready to go? Let's make a start. What I'm going to do is I'm going to create a sketch on this surface here, and from that we can define the path that we're going to make our recess around. And again, just repeating, any shape that you sketch on, any face that you sketch on, it converts the borders into geometry, as you can see. So we're going to offset that. And we're going to offset this one here by -3.75. Okay, exactly halfway between that gap. Yeah? You should get a line that looks like this. That's in blue because obviously it's not defined, but it actually is. And yeah, that's pretty much it. Okay? Great. Does everyone follow along with that? Does anyone have any problems so far? So we've defined, and this is going to be the path that our thing travels around, right? So the path that we're going to be cutting along, right, to make our little recess to rest our hands on, right? But the other thing we sort of need is the actual cut that we're going to make along that path, okay? And what's challenging about that is, where do I put the sketch, right, that I wish to cut it along? Now, what's important is that that sketch must lie or must touch in some way this line here, because otherwise it's not going to be able to extend that along the path. So we can think of many different planes that we can draw on. And what I'm going to do in this case is I'm actually going to draw on this yellow plane that's already been defined, which is the front plane. Okay, I'm going to draw on that. But you'll notice that you can't actually see anything on there, right? It's kind of troubling. And so we could, I guess, try and figure out where that line is, which is what I'm going to do. Or what you could do is you could go into a bit more detail and you could sketch from this plane here instead. And then you'll see that line there. So it's a bit complicated, but in our case, what we're going to do is we're just going to imagine, right, because we're sketching in this plane here, we're going to imagine that we have a line here that we want to line it up with, right? So what I'm going to do is I'm just going to draw a construction rectangle with the height constrained to the thickness of that, and the length of this equal to 9 millimeters. Okay, because that should line up with the edge of that. Okay, what's up? Oh, easy. We're just doing some CAD. Feel free to watch along. There's a live stream as well, so you can always watch that. So 9 millimeters takes us to the end of this, but we obviously want to reach the center of that line as part of our sketch. Okay, so instead of 9 millimeters, what we're going to change it to is 9 minus 3.75 because I can't do maths, and that should take us towards the middle of that line. And what we're going to do there is we're going to draw the sketch with a little arc. And what I'm going to do is I'm actually going to draw, first off I'm going to draw a line, because what we're going to do, sorry, I'm going to do this in step by step that makes sense, right? I'm going to make a circular arc. I'm going to make a circular arc that cuts into this material. So it's going to look something like this. Can everyone sort of imagine what I'm trying to do here? I'm trying to make that circular little recess cut into the material, right? So in order to do that, first I need to define the radius that I'm going to cut out. And in this case, I'm actually going to go with 5.5 millimeters for a diameter for our little recess there, okay? Okay, so you can imagine that a recess is going to look something like this, yeah? Make sense? Bless you. Great, so now that we have that recess, we're going to need to line up the circle, the center of the circle to our line here, right? Our construction line. And so you can imagine that's quite easy to do. We can draw another line that goes straight up, and we're going to dimension this with a length of 4.5 in length. And I'm going to convert that to construction line because we're not worried about that. And I'm going to put the center of my circle on that. Okay, and you notice that's not touching just yet. Cool. Does everyone have that? I haven't gone too fast, yeah? Is anyone not there yet, where I'm at right now? Do you just need time or do you need help? Okay, great. Let me come over. Sorry. So leave the last sketch on the menu and reinitiate. So open the sketch. So leave the last sketch for right. Yeah. And then start on the sketch and restart, reset. It would then. I mean, I'm going to make that. We're making a little recess. Imagine that the table's going to have a little break on the side, and it's going to be a tiny recess. For that same purpose. You'll see in a moment why it looks like that. It's a very common feature in all of my sketch. Yeah. Anyone else having issues? Okay. So, alright, so what we're going to do now is, now we're going to follow along with my mistake and change this to 5.5 times 2. Because I totally didn't miscalculate that. It's meant to be 5.5 times 2. It's meant to look like this. That looks way too big. What do you guys think? Can we like change that to like 8? No, I can't do 8. And then make that. Oh wait, no, never mind. I just raised this to 5. Yeah, that was it. So I'll raise that back to 5. Sorry about that. So I'll make that 11 radius. 11 millimeters diameter, and I'll make that 5 millimeters high. Okay? Does everyone have that? For those that do have it, stay there. What I'm going to do is I'm going to redo the whole process for those that missed out. Okay? Are you ready? Does everyone who has that hold tight? I'm going to redo the whole process. So let's stop the sketch. Let's redelete that sketch. Great. Okay, so just re-explain, because that bit's a little bit difficult, is I'm going to create a sketch. Oh, what is it doing? No. I'm going to delete that sketch there. All right, so what we're going to do is we're going to draw a sketch that has to reflect the profile of our cut that we're going to make. Okay, which means that we need to put it somewhere that can sort of be reflected on this path here. Okay, and so what I'm going to do is I'm going to draw it on this front plane here. Yeah, front plane. Okay, and I can draw my sketch on there, right? And I'm going to draw the cut that I'm going to make. So what I'm going to do is I'm going to find a position that I want to make using a rectangle, and I'm going to make sure it's construction because I don't want it to be physical geometry. I can select the origin, and I can map out exactly where that is to be 9 minus 3.75. Like so. Oh, yes. 9 is the distance to this line here, and then minus 3.7 from the very tip. 2 plus 7. I told you I was terrible at maths. I really warned you. It's 9.5 minus. It doesn't matter too much. Yeah, this is embarrassing, isn't it? I do engineering. Cool. So we have that measurement there. And now I want to make a circle that is 5 millimeters from there. Okay, so I drew a construction rectangle to find that point, which should line up with that line, as you can see. Yeah, and then we'll draw a line that extends out of that, an extra 5 millimeters, again by construction. Yeah, then what I'll do is I'll exit construction mode there, and I'll draw a circle that has a diameter of 11 millimeters. Yeah? Then what I'm going to do is, because I want to cut out that entire shape, I can either leave that circle as is, or I can draw a line, horizontal line that joins that, and cut that out. But you realize that because I can cut the full circle, it makes no difference to my cut. And you'll see this in a moment. So let's stop the sketch. That's pretty much all we need. And all we need to do now is we need to use the sweep function. So go to create or destroy, and we'll go to sweep. Okay, it's asking for the path and the profile. So we'll select that because we want to cut that shape out. And we'll go to path and we'll select the path that we want. Now, will it actually let me move that around? Please don't tell me it needs to actually touch, because if it does, then I'm screwed. Distance, the full length. Nope, it's not going to let me cut. Great. It's because the sketch is not actually touching. I forgot about that. What we can do to sort of trick that is right-click your sketch. Hang on. Redefine sketch plane. That's it. Define sketch plane. And what we can do, so every time you notice that, you'll notice that my sketch is not actually touching that line there, which means it's not able to actually make that extruded cut, which is my problem. So sorry about But what we can do to sort of correct that is we can actually move the sketch onto the correct plane, right? And to do that, we're going to need, hopefully you learn a bit about reference geometry. Did Michael teach you reference geometry? It was kind of like, what do you guys want to do? Radio. Okay, so what we're going to do is, okay, my aim is to move the sketch, and this is something I'm making up on the spot. We need to move the sketch onto this line here, right?
Can't you just like right-click on the sketch and then move around?
Not here.
I mean, right-click on the actual sketch, right-click and then move.
We can move it. We can move it, but like there's a more formal way to doing it, which I'll do. What we're gonna do is I'm gonna create an offset plane, and this is to show reference geometry. I'm gonna create an offset plane that represents this plane shifted 20 millimeters. Okay, and the reason why I've done that is now I can redefine the sketch to not be on the plane that we just drew, but on this new plane. Okay, so what I've done, just to show everybody again, is I've created an offset plane through construct. And reference geometry is very useful. I'm not sure if Michael actually went for it or not, but reference geometry is very useful for creating geometry on different sort of areas, right? So I'm going to offset this plane here, and we're going to slide it back 20 millimeters, okay? Like so. And now what I can do is I can right-click and redefine sketch plane. Why is it not letting me... Oh, right. Okay, hang on. Let me move this sketch before. Excellent, excellent, excellent. Great. So what you'll notice is that when I press redefine, it doesn't actually copy. It actually goes back in the timeline because it's trying to define a sketch, right? Which means I need to do the offset before my sketch. Does that make sense, everybody? Is when I'm trying to redefine the plane that I'm sketching on, usually that means that you need to actually define a sketch plane, then do the sketch, and not do the sketch, then choose the plane, right? Which is what's happening here, okay? So what I'm going to do, I'm going to make this work, is we're going to roll back one slide. Yes?
Are you not able to, like what you had before, just drag it?
Yes, we can, but I'm going to try and do it this way. To show you reference geometry, given that I have been put in this scenario. But yes, you can move it by right-clicking and then just moving it. What we're going to do is we're going to construct an offset plane, and I'm going to shift that back 20 millimeters. Then I can reproduce the sketch in the timeline, and then I can redefine it onto this plane here. Okay, so that's what I've done there. Do you want me to repeat it one last time? Yes? I got one yes, that's good enough. So, we've drawn our sketch and I want to move it, right? And as you said before, you can just right click and move and copy, right? But what I'm going to do instead is show you a bit of reference geometry. What we're going to do is we're going to go to the timeline in the bottom here, and we're going to roll back one step. We're going to roll back one step. And then once we've rolled back one step, I'll then go to construct and draw a sketch plane here and push it back 20 millimeters. Yeah? Does everyone get that? So I'm creating a new plane that's sort of displaced by some distance. Okay? And now back in the timeline, I can go back forward in time and see that the circle is there. Can you guys see that? And now, because that sketch has already been made, I can redefine the sketch plane, and instead of drawing it on the original front plane, I can move it to this shifted plane here, and I can press OK. Okay? Everyone get that? Yeah? Great. So, now that we have that, hopefully now we should be able to do our sweep. So I'll go create and I'll go sweep. I'll select my shape in the profile and then I'll select the path that I want to trim around. And you'll notice that this happens, right? Because it's going to cut this rectangle out. Yeah? Obviously, again, you can go into operation, you can go join, and we'll have this sudden huge tube on there. Doesn't look pretty. We can do intersects, and we can just keep that little slitter there, or we can do cuts. Okay, if I press OK, you'll notice that suddenly we have a little. And yes, you always got my Mac. Anyone else? Anyone else not having this yet? One person, 2 people, 3 people. Does everyone sort of have that? Does everyone sort of have that? Yeah? Okay, cool. So, great. Cool. We have a tabletop. We have a tabletop. And what I'm going to do is, we're first going to do a very basic table. We're first going to do a very basic table. And then we're going to render that table, and I'm going to leave it at that. Then, if you want a bonus exercise, we're going to try and make the tables stick on in different ways. Okay? So, I'm going to jump onto a little bit of theory here. So, if you don't mind me switching back over. Where's the transition button? Studio mode. There we go. Easy. So, let's jump back onto the slides for a moment. So hopefully you've made some sort of CAD, and I know we don't have colors on it yet. We'll get to that. And here's sort of the theory bit that we need to go into, okay? So, here's your bit of theory for today. In CAD, we've been working with singular models so far. So, we're working with one single sketch. We're working with one, what we call body, okay? We haven't really worked with multiple bodies yet, but you realize that almost everything in the world consists of multiple bodies stuck together. Right? Nothing is usually ever a single model. We usually make models from multiple connections of multiple components. And so what we actually need to do is we need to build what's called an assembly. Okay? And so what you'll notice is that what we're constructing is individual components. So, what we've just done is we modeled a leg and we modeled a table. Right? And so we've modeled those, and yes, we've done that sort of model. But in saying that, when we make those models, those are individual what we call components. Okay? And components are individual parts, but we can join multiple components together through assembly. Now in Fusion, the system is actually a little bit funny to other CAD softwares. So just keep that in mind. But using components separately allows us to do several things. Okay? Allows for animations. So you can imagine that we're going to model joints together. And we can model and animate those joints actually moving. Okay? And I might do one as an example in a little bit. We can do renders of multiple parts together, right? And we can also do structural testing of joints, which is kind of important. So when we are working with assemblies, we are working with multiple components, and it's important that we convert everything to components, which I'll show you in Fusion. Okay? In order to do that, what you need to understand is what is a joint. I keep saying that. And joints basically allow us to join multiple parts together. I know it sounds weird. Well, we can join multiple components together, okay? And what we're doing is we're limiting what's called the degrees of freedom, okay? We're limiting their rights, okay? We're going to limit the degrees of freedom so that they can only move in certain fashion, certain ways, okay? For example, what's a good example here? Right? For example, this staircase here. Actually, no, my table is a much better example. Right? Let's imagine this table here. This table has locks, right? If I lock the table in place, then the table only has 0 degrees of freedom. It's not able to move anywhere. Well, in theory, not able to move anywhere, right? It's fixed in place, right? It has no degrees of freedom. If I lock one foot, then if 1 foot stays placed, it technically only has one sort of direction it can move in, right? Just sort of swimming around the same spot. So it kind of has 1 degree of freedom, right? Let me lock that wheel back in place. Sorry, no, I shouldn't do that. If I unlock both wheels, then suddenly this table has 2 degrees of motion, right? Because now I can translate left and right, and it has 2 axes on which it can move. So what's important that I'm trying to say from this, from moving this table around, is that what I'm doing here is I'm trying to limit, using joints, which is why I'm locking the wheels, I'm trying to limit the number of, motion, different types of motion they can do, right? The maximum motion you can achieve is 6 degrees of freedom, because you can imagine I can translate, so I can move forward, back, left, right, up and down, and I can also rotate in those 3 directions. So you'll learn that you'll get 6 degrees of freedom for any motion. And what we're doing with these joints is we're limiting the amount of degrees of freedom based on what joint we use, okay? So we'll do a simple joint, we'll do the render, and we'll jump back and I'll show you some other joints as well, okay? But that's the premise of joints. And before we get into that, we need to understand joint origins, okay? And joint origins is the last little bit of theory, and these define the point of contact or alignment between the 2 shapes, okay? And joint origin definition is actually kind of important in Fusion, okay? It's its own funky system of doing it. And pretty much what we're doing is by drawing a joint origin, we're defining axes on which the degrees of freedom may be limited, okay? So if you look at this diagram here on the bottom, you'll notice that there's a circle with a semicircular cut in the inside, okay? And that represents the X and Y direction, okay? And then the color So on here it looks like white, but if you look from on the side it looks yellow, okay? And that defines the Z direction. And what's important here is that these joint origins are defined exact because when we make a joint, we need the two joint origins to line up. So in particular, this semicircle here, the semicircle needs to line up between the two components of the joint, right? And only when these two line up will the joint actually work, right? And so if you define them incorrectly, you'll find that your joint doesn't make any sense. So it's important that you do that, okay? That's pretty much all we need to do. Now you can obviously define joint origins in two ways. When we apply the joint, as I've shown them in a very brief period of time, you'll see that when you, as soon as you click the joint command, it will automatically create this for you. Okay? Alternatively, you can use the joint origin commands and create your own origins from there. Okay? So you can do that as well. Cool. Does anyone have any questions about that?
So like the automatically created one, where would they tend to put themselves?
They tend to put themselves flat on any face that you select. So you'll see this in a very short period of time. Okay, I'll show you. I'll do it. Cool. Any other questions? Excellent. Let's get started here. Let me just quickly clamp this mic on. Great. So, oops, I need to be in present mode here. I need to jump on here. I need to switch to this scene here. All right. So, I now have my table. And I'll also have, if you remember, we hid our original body here. Okay? So we have our table leg. Now you notice that they're touching. That doesn't actually matter. We can move it at any point in time. Okay? So let's take a look here. The very first thing you need to do with any sort of assembly is convert some of these models into components. Okay? So the way to do that is just go assemble, new component, and we can choose our body here. So from bodies, I can select my body here, and I press OK. And you'll notice it will convert the body, which is our original model, at least for the leg here, into component 1. You guys can see that, one semicolon 1. And what I can do is I can do the same for the other one. So I'll go assemble, new component, from bodies, and I'll select body 2, which is our tabletop there. Okay? Excellent. Now, before we can actually stick our legs onto our table, the first thing we need to do is we need to define this joint origins. You remember that? If I just join it straight away, right, which I'll show you real quick. So the joint command is in assemble and joint, right? And so you'll notice that this sort of symbol comes up, right? Remember that symbol, right? We can select the top of the cylinder here, like so, and now it asks us to define a second one. But you'll notice that I can't really fix any point on that second joint origin, right? So I select the middle of the table here. It might not work. It doesn't want to work on me. Excellent. Why does it not work? My goodness. All right. There we go. So you notice that it needs to fix to a certain point here. Okay? It's quite rigorous, I know. It likes to rub it around. So let's repeat that. So you notice that it needs to fix to a certain point here. It doesn't like to, I can't stick it anywhere on that face. I need to actually stick it on a common point where it's center or the side here. Okay? And that is just showing that it's rigid, by the way. The reason why it's vibrating is just an animation. But you'll notice that it fixes on the edge here. That's not very pretty, right? No one's going to want that margin table, right? We want that sort of to be fixed in place. So what I need to do is I need to create a sketch that represents points under the base face on which I can mount those points to. Does that make sense to everybody?
Is it easier to make a rectangle rather than...
What do you mean by that?
So you'll sketch a rectangle with a margin.
Yes?
Yes.
Yeah, that's all I'm doing. Okay, so you can see that this is obviously not going to work. So let's cancel that. And let's create a sketch on this bottom face here. Okay, and what we're doing is we're defining a rectangle or square that has the corners equal to points that I want to join my legs to. Does that make sense, everybody? Yeah? So what I'll do is inside the sketch, I'll just offset these by a distance of -5, which is the radius of those cylinders that we originally made. Okay? And that should sink it far enough. Like so. Okay? Does everyone have that? Yes, thank you. Anyone else having issues? Almost there? We're just offsetting the base rectangle by 5 millimeters. Yeah. That's okay. So, does everyone have a sketch on the square on the bottom? Yeah. Right. So, we can stop that sketch. And what we can do is, again, we're going to repeat that process now. Okay? So, I'm going to go joints in assemble, denoted by the letter J. Then I'll select Farhan. Take my coat with you. How about the pizzas? But this will smell like pizza. Look at like this way. So the outside. Yeah. So the outside smells like everyone else thinks they got it. It doesn't matter how much it works. The pizzas are way worth it. Yeah, pizzas are way more fun than me smelling like pizza. Rightio. It doesn't really smell all that much on the boxes. It's like a little bit of oil, but whatever. Okay, so what I'm going to do is, again in joint menu, I'm going to redefine that joint origin on the top of the cylinder, on the leg. And then what I'll do is I'll flip to the underside, and I'll select this point right here, but make sure that the point that you're selecting is actually sort of parallel to the face, right? It's flat with the face. You notice that you can do this, and it's a little bit weird. What will end up happening is the leg will actually go into the table, right? Because the two joint origins must lie flat to flat, okay? Flat face, right? So make sure that when you're highlighting over, that the joint origin is nice and flat on that surface, yeah? You notice that when I do that, it applies a joint like so, and then I can press OK. And look at that. We have our first leg of 4. Great. So, now that we have that leg, we can now sort of, I guess, do the same for the other 4 legs. Other 4 legs. There's actually a mystery leg in the middle. And so you can think of multiple ways to do this, right? One way you might have, yes? You can do rectangular pattern. That was more interesting. You can go into create and we can go rectangular pattern. Good suggestion. Which is one way. But my problem is whether it actually mimics the joints. Now, I believe it does, but I'm not 100% certain, which is why I prefer to do it by just placing new legs. So feel free to do it however you want. In our case, because I'm not too worried about, I guess, mimicking our model too much in terms of making it sort of ready for simulation, I just want to design this CAD out, right? And so what I can do is follow exactly your steps, and we can do a rectangular pattern. Now, the other way, obviously, is to, to copy the leg 3 more times, and then just stick the leg to the 4 corners of the table, yeah? So you can just repeat that process again, or as we said, rectangular pattern, or you can do a circular pattern if you're feeling pretty interesting. All we need to do is we need to change that, and you select the objects, which is going to be this component here. Select the objects, which is going to be this body right here. Never mind, really? That's right. Components. We need to copy that component in there. And then for the direction, we'll select this line here. And I will move it a distance of let's take a look. Drag that along. Wow, we got 3 legs there. We only want 2. Well, 13 legs. Well, 13 legs on our table. And the extent of that should be up to there. So we'll just drag it up. And we'll sort of give a good rough guess. Who doesn't like this table? Yes, great. We probably want something a little bit more realistic, so let's sort of bump that down to 8 legs. 138 legs. We'll just do 8 legs there. Excellent. Great. Cool. So here's our 8 legs. And so it's 84, I think it is. But you can always check with the inspect tool. We can measure that line there. 84 millimeters. Easy. Okay. It's got some nice legs there. Okay. Probably no one could fit the legs underneath the table, but we won't worry about that. That's a design consideration for someone else to worry about. And so what we're going to do here is, oh, don't do that. Pan it and move it around. And all we can do now is we can do the same thing, and we can sort of, so now you can imagine just mirroring it. You can mirror it across the other side, or we can rectangular pattern. So my objects in this case are going to be 1, and then 2, 3, 4, 5, 6, 7, 8. Actually, because I'm feeling interesting, I'm going to leave out 4 and 5. And what we're going to do is we're going to leave a quantity of 2 and a direction of 84 in this direction here. Oh, don't copy that table there. And the direction is going to be that line there. And in the quantity of 84. There we go. And we're going to create 32 of those. Just 2. Excellent. There's a lovely table. Okay, I know it looks pretty. And we're going to be now moving on to rendering. Okay. So what we've done is we've created this interesting margin table. And what we're going to be doing with this is we're going to be rendering it with materials. Okay. So does everyone understand how basic assembly works? Somewhat. Basic joints. Okay. I'll show you a bit more complicated joints if we have time, but I do want to get through the renders first because I feel like you need to see the render. So, having said that, congratulations, you've modeled the table ridiculous a lot. And what we're going to be doing is we're going to go into the render workspace here. So, for the first time ever, we're going to explore past model, and we're going to enter the render workspace. So let's click render, and it sort of does its own funky thing. Okay, it takes a while to load. Okay, just a preemptive warning, rendering tends to kill your laptops because it's a very process-intensive action. So it will sort of drain your computer a little bit, but we can tweak those settings to make it not kill your laptops. Okay, and I'll show you those settings. Right, so we have this component here, and you'll notice that it kind of looks metallic for the moment. Okay. Do you want your metal to be made of metal? Yes. Wood? What? Who doesn't want aluminium margin tables? Like, that's the next one. Glass it is. Alright, so we're going to jump into appearance here. And what we can do is we can either change the physical material of what we're working with, right? And to do that is in here, physical material. And so we can select from a series of materials. So William said we're going to glass, we're going glass. And we'll cook my laptop by changing it to transparent anyway. And what we need to do is we need to drag and drop it on a particular model. So let's say I want to make that leg glass, and all those legs are now glass. And let's say I want to make the rest. Why is that gas? Is that gas? Make things anyway. I'm going to make the rest metal. And we're going to choose aluminium. Do they have my favorite one? 2014. There we go. Excellent. Interesting. Definitely a table. And what I'm also going to do is we're going to have that classic lime look inside the middle, right? Because there's no way a mahjong table is mahjong without a lime face, right? So I'm going to go into appearance. And what the point of appearance is it doesn't actually change the material, right? And all it does is it changes the look of it, right? So even though this might be made of glass and this might have a metal with top, we can always change the appearance to make it look like it looks like something else. But I'm not going to do that. I'm going to leave that as is. But I'm going to change the face of this central plate here. Okay? What we're going to do is we're going to look for, I think it's not plastics. It should be paints. Yes, we're going to paint our color. And we're going to have let's go with a powder coat rough. And I want green in this case. Now, you might need to download it. So there might be a download button there. Just hit the download button and you might need it. In my case, I'm going to go with green. And all you need to do is, again, click and drag it onto that surface. And now we have the famous sort of jade green texture. Okay. That's it. Okay. So what you should get, and again, I urge you to just play around with this on your own. I'm just messing around here. Just select what material and physical, what material and appearance you want for your model. Okay. Great. So now that we have that, the next thing is to go into scene settings here. And scene settings allows you to change, what your model might look like. Okay. So environment. The first thing to do before anything is go into your environment library. And let's take a look at some of these places here. So what do you think looks like the most fitting place for a mahjong table? Out of these. You only get to choose from these, right? What do you think is the most? Plaza? In the plaza. We're going to play mahjong in the plaza. So you can download each of these scenes and you can download your own custom environments as well, right? See, if you had your own custom environment in mind, you can scan your environment, chuck it in here. And let's chuck plaza because we're working in a plaza now. There we go. My laptop's starting to potato there. Was it not actually adding it in? Apply to scene. Background, environment. There we go. All right, so we're in a plaza here. Pretty cool, pretty cool. We're working in a plaza here. And so this makes no sense at all. What we're going to do here is we can change things like the brightness. Just going to make our scene super duper bright on a nice sunny day. We can make things sort of moody for a nice mahjong game there. And we can position our sort of model there. So there's a ground level there. Okay. There we go. Great. So we can do that. Flatten the ground. Ooh. Oh, look at that. Oh, look at that in our tiny table in front of some temple there. Excellent. Just what I wanted in my life. I have no idea. I think it is. Hey, that's... Oh, okay. And then you can select reflections if you so wish. Now, reflections is not going to show up much because we have glass here. I know. But we can change things like the roughness. And we can change our camera. We can even change our focal length. Oh my goodness. We can change our focal length too. Alright. Awesome. So, we can change a bunch of things. And I urge you to just play with it on your own. Okay? I'm not going to go into too much detail. And the next thing now is to, we can add some decals there, like it's a car. You can add your own stuff there as you wish. Again, play with this on your own. I'm not going to go into too much details. I'm like mucking around here. And what we need to do is go into render here. We need to save our design. I haven't saved my design. Let's call this poopy. No, destroy. Yes, because this is the theme of today's workshop. Rightio. And so we can hit render here. sync to the cloud already. Here we go. Hit the render menu and this window opens up, okay? The window is supposed to open up. Why?
Maybe just drag this up like that.
Appearance. There we go. There it is. Lovely. No. Don't leave me. Alright, so inside the render menu, we can sort of tweak certain parameters about it. Okay? So what you'll notice is that Fusion has what's called a cloud render. Okay? So the cloud render basically runs it on the cloud and does the processing, so you don't need a nice expensive computer. Right? Obviously, we're too poor for that, so we're going to go with a local renderer, which means running on our laptops, and we're going to go with standard render quality. Okay, and we can change several things here. So to have some custom ones here, I'm going to go with web 800 by 600, 0.5 megapixels, because we need the lowest possible quality so our laptops don't actually crash. Okay, so we're going to select the lowest possible one there. And obviously, when you're in your own time, select something that's higher quality so you can actually show your friends. But in our case, we're just going to go with this because, yeah, it's going to crash, right? And what we can also change is in advanced settings, we can even go from final to draft. So it's the lowest possible quality, right? And that means that our potato PCs are not going to die here today. Okay, we don't want anything dying, right? And all you need to do is press the big fat render button. And it does its thing. Now, you notice that obviously here there's a cloud symbol that's crossed out, which is good, because that means we're not wasting our free money. And so it's just about ready to go. Takes a few seconds. There we go. Loading bar's done. I can press the plus button on that, and that's our image, which totally makes sense. I'm going to post this on the Chrome page. Nice. I'm going to call this nice. So if we jump onto our desktop here, there we go. Look at this. Wow. This is great, right? So you can see that quality there is horrendous, right? Okay. But does everyone understand like that whole process? It's quite easy, and it's purely just having fun and experimenting and setting your own materials. Okay. Totally doesn't make sense when I do it here, but when you do, just play around with it. Make sure you do local renderer, don't do cloud renderer, you're wasting your money. But other than that, that's pretty much it, okay? So in terms of rendering, that's all you need to know. Cool? So jumping back onto the slides here, because we had slides to start with. Yeah, so that was the rendering slides in case you want to read it. But the whole point of rendering is kind of more just to show off your model. Okay? Because obviously, when we create these physical models, you want to show it what it looks like in the real world, right? You don't want to just model it and leave it at that, right? We can you'll notice that I did that render quite quickly. We set materials, we mucked around with that, and very quickly we turned our model, right, into something that we can at least present, right? Obviously, my model's a bit weird, 8 legs, but we can always show that model off and see what it looks like in the real world, right? Before we actually make it. That's sometimes cool, yeah? So, that's pretty much it in terms of what we need to do. What I will show you, not that you need to do it for this CAD, because I think it's going to take way too long, is I'm going to show you a few of the extra joints that you can actually apply. Okay? So I don't think I have any more slides. Yeah, that's it for today. So that's what I render that I did before. Looks the same, but this one looks boring. This one's wooden with 4 legs. Come on. Who orders this kind of table, right? Alright, so let's sorry, just give me a moment. Let's switch back to our Fusion here. Okay, so now we can take a look here. So here's my original model here. Our original boring table. Okay, we're going to work off here. Great. You'll notice it's missing legs. This one's just free floating. And we'll just show this legs there. Okay. And I only want to demonstrate this. I don't want to have you guys make it because it does take a while to set up. Sorry. These are actually done a little bit differently. So this looks like a standard bog standard table, right? But oh, that looks weird. But what you'll notice is that one of these joints is actually a little bit funny. Can you guys see this?
Oh, yeah.
It's a slider, right? Which means this doesn't have to stay in place. Now, it's very hard to actually move that because it's weird. But this here, so maybe I can show it in edit joint here, is actually a joint that can actually slide in place, like so. Whoa, so cool, right? So we can actually move this slider joint in and out. And what I wanted to show you this is because the joint that I've applied is called a slider. And I can animate the slider, right? Right, so it's animating that slider and you can slide in and out. But you'll notice that there is 1 degree of freedom here, isn't there? There has to be 1 degree of freedom for this to happen, right? So joints, as I showed you, don't just have to be 0 degrees of freedom, which is when it's fixed, when it's called a rigid joint. We can also apply sliding joints of about 1 degree of freedom in this way. And now there is another sneaky one, which I need to find. Where is my sneaky joint? Which is this one here. You notice that this one here has a little pin on it, right? So what I've done is I've made a little extruded cut into my table and then inserted that pin and made that part of the joint. Why is it my Google going off? You'll notice that there's a little pin there, right? And I can align that pin. And this particular pin here, I'm not sure if I can show it. I think I can. It's a rigid joint there. This one here, edit joint. I can change that to a revolute joint, which means that it can actually spin in place. Okay? Because it's on a cylinder pin, a little cylindrical pin, and so it can actually spin in place. And again, that's still 1 degree of freedom. It has to stick in there, but it's allowed to spin in place. Right? So that's rotation, and that's 1 degree of freedom. So I just wanted to show you that, just to show you that there are different degrees of freedom that we can limit, and there are different types of joints that I haven't gone into here, like cylindrical, which is like this. Right? But we can limit that, right? But that is a possible way. I know it looks terrible, we're not going to do that, right? And obviously with all of this, you can enter the animation library, and we can animate everything that's going on, and we can animate all those mechanical linkages, right? So I just wanted to show you that as an extension because really when we do CAD, we're not really working with one individual model. In most cases, you're actually modeling multiple bits to join together. And usually that involves some sort of assembly, and that's why we have that, okay? But having said that, that's pretty much it from me. Let me just quickly slide that back over. Okay. That's pretty much it from me. Did everyone find that useful? I know it's a bit more arbitrary than the first two, but this is sort of like a work in progress for advanced CAD that I'm working on. And it's sort of almost there. I do need to refine a little bit, but if you do have any feedback from any of these workshops, please let me know. Okay, so I wrote all of the ones that you see this done. But this is sort of like the conclusion of our big two series. There is one happening in week 9. I know, really terrible timing. That's going to be on what I'm calling the principles of engineering design. And this is something that I'm writing myself because I see a lot of students misunderstanding things like stress concentrations, material choice, cost analysis, stuff like that, and understanding how we can make really effective design work. So I'm actually in the process of writing that workshop up, which is happening in week 9, Monday. So I'm going to announce this on Facebook, of course, and I'm going to newsletter, which we haven't been releasing, I know. But the hope is that by the end of that week 9 workshop, that'll be pretty much it from me in terms of T1, and then we'll sort of have week 10 off. I think we're going to have a really big social on the Friday of week 10, where we're not going to order Domino's pizza. So for once, it's going to be Arthur's Pizza, which is not a joking. It might be something different. But yeah, so hopefully that was useful. Again, I'd love some feedback. Again, this is the first time we're doing advanced CAD and with assemblies and all that. So
when you say Fusion, I would usually just like rename those layers if you can. that just helps it easier if you can.
Yeah. When you do one, two, three.
Especially working with multiple
Body 1 is such a descriptive name. Body 1 and body 2.
Yeah.
And you can hide the bodies, right? You can hide body 1.
I find like if you give them names, then when you find it's just easier.
Right? So good. Yeah, so we'll go into that. Any other, so again, you don't have to say it until we sort of need to come up soon. But yeah, thank you so much, guys, for sticking around to our third workshops. We usually don't get very many people, as you can see in our last workshop. It was an absolute pleasure to teach all of you, and I hope that you got a lot out of this, and hopefully you can expand your designing stuff into the future. We're obviously going to be running more workshops into T2 and T3 to try and make it a bit more complicated, especially a week 9 workshop is going to be a purely experiment by me. But yeah, thank you so much for coming. Let's run a truck for me and the Create team. I would like to thank you for attending on this very late night. It's going to be freezing cold now. Anyway. Cool. That's it for me. Thank you.